Hi, and welcome to another video in the series about big integers. I spent the last two episodes talking about addition and optimizing its performance. Today, I will discuss subtraction and multiplication. I thought that subtraction would be quick and easy because it mirrors addition in every way. Except one. Remember the behavior I implemented for addition. When it overflows, the result automatically grows in size. This raised some concerns about optimizing memory allocation. But for subtraction, you don't get an overflow. What you may get is an underflow when the left operand is smaller than the right operand. And this opens a whole new rabbit hole, because what does it even mean for unsigned numbers? Indeed, when subtraction underflows, it means the result is negative, while our data type is supposed to hold a non-negative number. There are two ways to deal with it, or two legitimate behaviors. The first one is to throw or return some sort of error when subtraction underflows. That's like saying negative numbers can't happen. The second one is to do exactly what the CPU does when it performs a subtraction. The number wraps around and the carry or borrow flag is set. For instance, 0 minus 1 produces as many Fs as your data type can hold. What does it imply in terms of code? I'm offering both options. Either if you set wraparound to false, then it will throw and stop. If you set it to true, the code will do nothing. The carry is discarded, and the result keeps the size of the biggest of the two operands. Let's test it. Wraparound is set to true, variable a is 0, and variable b is 1. So a minus b underflows, and the result is what I was expecting. Two words filled with Fs, because the original variable a was 2 words long. However, the outcome for d is wrong. When you think about it, it's exactly what operator plus is supposed to do. It assumes the number is positive, adding 1 makes it overflow, and the size grows. Again, this is totally wrong in this context, because one should be able to do minus 1 plus 1 and get the correct result. The issue we have here is about consistency between how overflow and underflow work together. The fix is quite simple. I need to replicate the logic that applies in case of underflow to operator plus. Specifically, if wraparound is set to true, the code here will not execute. The last carry will be discarded and the number will not grow. And if wraparound is false, the existing logic for growing and keeping the carry applies. Let's test it again. Okay, this is the intended behavior. And if wraparound is set to false, well, we can't see the outcome because it throws, which is again the intended behavior. Problem solved. A very interesting insight, in my opinion. Now, let's move to multiplication. I implemented the naive algorithm. That is, the one you learn in grade school. And its time complexity is n squared. There are more efficient ones, which I won't be doing, at least not now. Bear in mind that those algorithms, while more efficient in terms of big O complexity, involve increasingly more overhead. In practice, the naive algorithm will be optimal for smaller numbers, and some implementations would switch to different algorithms depending on the input size. I understand the naive approach is optimal until somewhere between 32 and 64 limbs, which looks good enough for me. As a reminder, this is how school book multiplication works. What my code does looks more like this, except that there is a running sum after every multiplication. So the code should be pretty much self-explanatory. I rely on unsigned int 128 to handle the product, the addition, and carry propagation. S looks like it might overflow because of the two additions, but it actually doesn't. Take an example with 1-byte numbers. The product is at most FE01 plus FF and plus another FF, and that still fits into 2 bytes. This is quite helpful, as I can pack everything into S. And what happens after is very similar to carry propagation in operator plus. Memory allocation is more predictable than in operator plus, in the sense that when multiplying numbers of size m and n, the result is of size m plus n at most. Also, there is little chance, comparatively to the addition, that the current capacity of variable a could hold the result. Therefore, I can allocate m plus n without any second thoughts. No regrets. You may recall that in operator plus equals, the plan A was to reuse the current capacity and only resize in case of overflow. Here it's the other way around, and this is the reason why the code I'm showing on the screen right now is operator star, not star equals. As I have to allocate memory anyway, my code pattern fits better into operator star with both operands passed by reference. I perform my allocation, which is unavoidable, and the return will be optimized with RVO. So, one allocation in total. Now, in operator star equals, I eventually call operator star because I don't want to duplicate my code, and the temporary variable a is created with the move constructor, which is cheap. Overall, there should be one allocation in total, and the two operators should be equally efficient. As a matter of fact, their runtime is very close. Anyway, this is just the naive algorithm, and I won't be doing any further optimization, as I believe I have sorted out the most material inefficiency. But let me know about your thoughts. You may have noticed that I do not perform any trimming in the addition and subtraction, but I do trim in the multiplication. Trimming is meant to reduce the size if the most significant limbs are nil. And I have discussed already that this would not immediately cause a memory reallocation, or rather deallocation, as extra capacity will be kept. The intended benefit was to keep the numbers as compact as possible, not to reduce memory pressure, but to reduce unnecessary subsequent computation. However, the cost of trimming by one limb should be close to the cost of adding or subtracting an extra limb. So I decided to live with it. On the other hand, in multiplication, the benefit could be much bigger. And this is why I trim both the inputs and the result. I feel that I'm not done with trimming yet, because in wraparound mode, probably there should be not any trimming whatsoever. That's it for today. Remember, the link to the Git repository is in the description. See you next time, and thanks for watching.